Hey, 5th grade, I wanted to help you out with this page in particular, the adding fractions page. Just because the bottom part, it has like pictures already drawn for you to fill in, and I just have a feeling that some of you might be confused by that, and especially since there's so many different ways that you can add unlike fractions, and that kind of narrows you down into certain kinds of thinking. But I wanted to go over with you this way and some other ways so that you can get through that page and hopefully remember, hey, yeah, I do know how to add unlike fractions. Hopefully you watched my video about equivalent fractions and that there are many equivalent fractions for every fraction value that you have. So this picture over here kind of steers you into certain directions or certain equivalent fractions to use. And so I don't want to say that you're limited to that, but you should be able to fill in that picture if you have a good grasp of adding and subtracting unlike fractions and equivalent fractions. So hopefully this video can help you out if some of that is a bit confusing to you. So I'm going through the example problem with you, and hopefully will help you understand how to finish that page. But you are asked to add 2/3 plus 1/2, and you're asked to fill in a picture with an equation, and in the middle you're asked to rewrite with common denominators. Okay, so there are different ways that you can go about finding a common denominator, and I'm going to post a picture in the comments of the flow map that we have for adding and subtracting unlike fractions. The biggest thing that you need to think about is finding a common denominator. You need to find a common multiple of these two numbers that can be your common denominator. Okay? So, I guess I could start with a way that a lot of people have in the past have learned how to do it, but it's not always the most efficient, especially if you're asked to give your answer in simplest form, which in 5th grade you're not asked to do that, so I'm not pushing you to do that. But anybody who's working with you might think that that's what you need to do, and so kind of want to bridge that connection. People use, typically, what they'll do is just multiply the two denominators together. And if you remember in class, we called this the butterfly method, even though that's not a technical math strategy term, okay? And that's where you say, I'm going to find a common denominator by multiplying the two denominators together. And if we're just listing common multiples of these two, like if I wanted to list the multiples of 3 and list the multiples of 2, then the multiples of 3 are 3, 6, 9, 12, 15, and we can keep going. Just name a few up to 5 and then see if there's any common ones. What are the multiples of 2? 2, 4, 6, 8, 10, 12. And we see that there is a common multiple of 6, and there's a common multiple of 12. We can use either one of those, and that's perfectly fine. And that's kind of where this picture comes into play here. Even though there's 12 individual boxes in each hole, okay, 12 individual pieces, they didn't use 12 as the denominator. They actually used 6 as the denominator. And so they grouped together 2 of the 12s to be that 1/6. And that's why you see the darker lines there. So they were actually using probably more of that strategy of where you multiply the two denominators together to get a common denominator. Okay? And so when you do that, you're going to have 6 in all, right? Or 6. But are you going to keep the numerators the same? Is 2/3 the same as 2/6? Absolutely not. They're not the same fraction, okay? 2/6 is a lot smaller than 2/3, okay? Because 6 are smaller pieces. So, using the butterfly method, what we say is we cross multiply. 2 times 2 is 4. 3 times 1 is 3. So 1/2 is the same as 3/6, that's true. And 2/3 is the same as 4/6, and that's true. And we can add those together, and we end up getting 7/6. Now, I never want you to memorize a procedure. I never want you to memorize just the butterfly method, and that's how you always solve these kinds of problems. I don't want you to memorize that because I want you to recognize even when you're my age and you haven't done fractions for a while, but in real life you're encountering this and you say 2/3 plus 1/2 and you want to say that it's, oh, what was that? How did I do that again? Or maybe I just add straight across. 3/5 maybe. But what was that way I did? I don't want you to be in that predicament. I want you to really understand the concept of you're creating equivalent fractions. And in that previous video that I posted, we found equivalent fractions using the visual fraction model or the ratio table thinking. So what did I really do to 2/3 in order to get 4/6? Remember, we said numerator, denominator in that ratio table thinking. Numerator and denominator, I'm going to put the abbreviations there. 2/3 is the same as what? Remember, we can do, if we want to draw my models on here, you know I'm all about making it make sense, okay? So 2/3 here. Oh, I want to do a better job than that. Two-thirds. 2/3, how do I turn thirds into sixths? By splitting each third in half. So I can just draw a line straight down. So what I did was I doubled the number of pieces, so I have 6 pieces, and I also doubled the number of pieces that were shaded. So instead of 2 shaded, I now have 4 shaded. So that's where that 4/6 came from when we doubled there. When we multiplied 2 times this 2, we were splitting this model down the middle. We were splitting the size of the pieces in half. Does that make sense? Or does that ring a bell from when we were learning this before Christmas? I sure hope so. The same is true for 1/2, okay? When we were multiplying 3 times 1, okay, we were tripling the number of pieces. So let's take a look at that real quick in the ratio table. So numerator and denominator, we had 1/2, and we tripled the number of pieces. So let me draw that for you. I have 1/2 here, and I tripled the denominator to be 6, okay? So what I did was I split each half into 3 equal parts. So there's that half split into 3 equal parts, and there's that half split into 3 equal parts. So I can use that same line there, okay? So now I have 6, but when I tripled the number of pieces in my total whole, when I tripled the number of pieces in my whole, I also tripled the number of pieces that were shaded. So I have 3 pieces that are shaded. So that is where this butterfly method, that's why it works. And I love how that so easily, like you can so easily draw that out and prove it. I just think it's very cool. I love math, yay. So when you add these pieces together, you got the same size pieces, 1, 2, 3, 4, 5, 6, 7, 6 in all. Which is, if you put these 3 pieces over here, you fill up that hole, and you have that 1/6 left over. It's the same as 1 and 1/6. okay? So hopefully all of that is coming back to you, and hopefully when we listed out those common denominators, you saw where we had 6 as a common denominator when we were listing those multiples of 3 and 2. And we also said 12 was a common multiple. If you notice on your page, all of these models are split into 12s, okay? And that's where they decided to group 2 of them together and call that a 6. So that's why you see those dark lines for every 2 12s is the same as 1 6. And so 2/3 is the same as that 4 6 that we got right here. So we shade in 4, 4 6. And then we also see that 1/2 is the same as 3 6. And 1/2 is really easy just to see here, right? You see that 1/2 there. But we're splitting it into 6 instead and shading in 3 6. Okay? So then we have 1 2 3 4 6 5 6 6 6 7 6. And you can notice if you brought those 2 6 up there, it would fill it in, and then there would be 1 6 down here. So that's where that 1 and 1 6 comes into play. So that's kind of what it's asking you to do. I don't know if this is clear as mud to you or if that made it really clear what you're supposed to do. But I know a lot of this, especially this butterfly method, probably rings a bell to some of you. It's not the only way to do it. In fact, sometimes this way gives you really large numbers that are more difficult to deal with. And I just want to show you an example of that if you have time real quickly. Now, sometimes using a smaller common multiple is actually more efficient. So, give me just a few more minutes. I'm not going to do an example from this page, but let's say we wanted to add together. Oh, I've got a good one. Probably a much better one than. Let me think. What would be good? Oh, okay. Let's say we want to add 5/8 plus 3/4. This is a good one. This is a great one. This is a great one. Because if kids, and I'm talking to you 5th graders right now, if you want to use the butterfly method, you would go, okay, I know a common denominator could be if I multiply 8 times 4. And so I'm going to do that underneath here. 8 times 4 is 32. Okay, and then I cross multiply. So 4 times 5 is 20. And 8 times 3 is 24. And when I add those together, I get 44 30-seconds. And you can leave that answer as 44 30-seconds, or you can simplify it into a mixed number. Either way is appropriate in 5th grade. Okay, so that wasn't too bad because I got an answer there, right? But let me show you an answer that probably will make more sense in your brain as far as how big this number really is. Because when we think of 30 seconds, it's hard for our brains to visualize 32 individual pieces of something. That's a fine answer, but there's a simpler answer than that. And if I look at 8 and 4, and I think about the common multiples of 4 and 8, multiples of 4 are 4, 8, 12, 16. The multiples of 8 are 8, 16. Wait a minute. I don't even have to change 8s at all. I can keep 8s exactly the way they are. I can change 3/4 to 8s, and then I will just be dealing with 8s. And for me, I don't know about you personally, but seeing 8s in my head is makes a lot more sense. If I was really doing and dealing with this in real life, eighths are a lot easier for my brain to comprehend and see and visualize. So I could leave 5/8 the same, but then I need to change 3/4 into eighths. So I'm thinking, what ratio relationship is there between 4 and 8? In other words, what am I multiplying 4 by to get 8? Because remember, if we were drawing this visual model out, and I drew out 3/4, how do I go from fourths to eighths? I split each one in half. So I'm doubling the number of pieces that I have. So 4 times 2 is 8. That means I'm doubling the number of pieces that are shaded. So I went from 3 shaded to 2, 4, 6 shaded. So 6/8. So 5 plus 6 is 11, and the size of my pieces are eighths. So I have 11/8 in all. And I don't know about you, but seeing 11/8 versus 44/32 is a lot easier for me to picture that amount. Like if I was talking about candy bars, or I was talking about pizzas, for crying out loud. If I have 11/8 of a pizza left, well, duh, I have a little bit more than a whole pizza left. I have 1 whole pizza and 3/8 of a pizza left over. And we know that pizzas come in slices of 8 usually. So to me, that's a lot easier to understand in real life situations. Now, are these values exactly the same? Yeah, all 3 of these values are exactly the same amount. So in 5th grade, we don't push so much for simplest form. We think it's good to know. But as you learn more about adding unlike fractions and you do it more often and become more fluent in it, you'll eventually break away more towards this kind of thinking with more practice and skill. So both of these ways are great ways, pretty efficient to do. Just sometimes this way you end up dealing with really large numbers, and I know 5th graders, you experienced that on some of your math and writing work this past year. So I hope that helps. I'll also do a video on subtracting unlike fractions because this video is already way long. So thank you for putting up with me and listening to me, and hopefully these videos are helpful. This was probably the video, and the subtracting unlike fractions video is probably the 2 videos I was like most nervous about making because it can be kind of complicated. So if you're getting stressed out over adding and subtracting unlike fractions, don't. Give yourself some time to work on these and find all kinds of things online to do if you have internet access. Practice them. Find worksheets online to print out and do if you want to. I know it's not probably what you want to do, but if you do want to get better at something, you do have to practice it, and you do have to struggle with it. It's not just something naturally that you're good at as soon as you see it the first time. So, yeah, I hope this helps.